Imagine stepping outside one morning and watching not one, but two suns crawl above the horizon, one blazing amber, the other a dim, blood-red ember trailing behind it. Your shadow splits in two directions across the ground. The sky above you is never fully dark, and the seasons, completely unpredictable, welcome to Earth, if it orbited a binary star system. This isn't science fiction. This is astrophysics, and it is absolutely wild. Today we are breaking down the scientific reality of what Earth would look like if it circled two suns. We are going chapter by chapter: orbit stability, climate chaos, alien skies, the evolution of life, and the real-world proof that planets like this actually exist. Buckle up. The universe just got a lot more interesting. Chapter 1. Can Earth even survive two suns? First things first, would Earth's orbit hold together, or would two gravitational bullies just fling us into the void? This is the core question, and the answer is gloriously complicated. Unlike a body circling a single star, a planet orbiting a pair of stars has to contend with two gravitational fields. And because the stars themselves orbit each other, the strength of those gravitational forces would constantly change. Picture trying to walk a tightrope while two people on either end are shaking it at different rhythms, at different intensities. That is essentially what an Earth-like planet's orbit would deal with every single day. Astrophysicists have mapped out two possible survival strategies. Planets can orbit just one of the stars in the binary system, a so-called circumprimary orbit. Or they can orbit both stars at once in a wide circumbinary orbit. In both cases, there are critical distance thresholds a planet must respect to stay dynamically stable. Get too close to the gravitational chaos in the middle of a binary system, and you are toast. The inner regions of disks around binary stars act as a sort of forbidden zone, where the chaotic effects of the gravitational tug-of-war make stable orbits extremely unlikely. But here is the twist. Even if a planet could form in such a dynamic environment, its long-term stability would not be assured. The planet could wind up being ejected into deep space or crashing into one of the stars. So, yes, Earth surviving a binary system is possible, but it is the cosmic equivalent of threading a needle while the needle is on fire. Now that we know our orbit might hold together, barely, let us talk about what two suns would do to our weather. And spoiler, it makes hurricane season look like a light drizzle. Chapter 2. Climate chaos, when the weather has two bosses. On Earth, our climate is driven by one star at one consistent distance with one set of seasonal cycles. Clean, predictable, boring, honestly. Now double the stars. Suddenly, your planet's climate is getting its orders from two commanders who disagree on everything. The habitability of planets in binary star systems depends not only on the radiation environment created by the two stars, but also on the perturbations to planetary orbits and rotation produced by the gravitational field of the binary and neighboring planets. In plain English, the two suns do not just shine at you differently. They physically tug your orbit into new shapes, stretching and squeezing it over time. And every time your orbit changes shape, your climate shifts. Here is where it gets genuinely surreal. Research shows that Earth-like planets in circumbinary systems would experience rapid Milankovitch cycles, oscillations in eccentricity, obliquity, and precession, happening on timescales as short as 1,000 years. For context, Earth's natural Milankovitch cycles, the ones that drive ice ages, take tens of thousands to hundreds of thousands of years. A binary Earth would cycle through the equivalent of an ice age and a warm period in a geological blink. And the seasons. Imagine this. During some seasons, it would be daytime continuously, with one star lighting up one side of the planet while the other star illuminated the opposite half. But that sunlight would not always be blazing hot, because one star would be much farther away. In other seasons, both suns would light up the same side of the planet simultaneously, one appearing much larger than the other. So some years you'd roast, some years you'd freeze, some years you'd have a sun rising in the east, while another is still setting in the west, and the concept of night becomes a philosophical debate. And yet, and this is the kicker, for Earth-like greenhouse gas concentrations, the variable forcing from two stars does not necessarily destroy the range of insulation values that allow for habitable climates. Two suns do not automatically mean an uninhabitable hellscape. The universe, it turns out, is more forgiving than we give it credit for. Speaking of the universe being dramatic, wait until you hear what the actual sky would look like. Because two suns in the sky is not just double the brightness. It is a whole different visual reality. Chapter 3. The Sky Above, a Permanent Light Show. Close your eyes. Picture the most dramatic sunset you have ever seen. Deep orange, bleeding into violet. The horizon on fire. Now add a second sun. A smaller one, a redder one. And it is setting about 40 minutes after the first one. Your shadow has been pointing in two different directions all day. Welcome to the sky of a binary Earth. Day and night would have completely different meanings on an Earth with two suns. When both suns were up, days would be much brighter. Nights would be different, too, because the suns would sometimes set at different times. And if the two stars are close together in the sky, they might appear to dance, one occasionally slipping in front of the other, causing brief, eerie dimmings of the light. The number of eclipses would increase as one sun moved in front of the other, maybe as often as once a week or so. Then there is the color. With two suns, the sky could appear in varied hues, depending on their positions and the way light scatters in the atmosphere, possibly leading to a broader spectrum of sky colors at sunrise and sunset. Imagine a morning where a yellow-white star rises first, painting the sky gold, and then a deep red companion climbs above the horizon 20 minutes later, washing everything in a crimson tint. A double sunset with stars of different colors casting moving shadows of orange and red. That is not a painting. That is Tuesday morning on binary Earth. And your shadows, oh, your shadows. Any object on a planet orbiting two stars would cast two different shadows, pointing in two directions, shifting throughout the day as the stars move relative to each other. Standing outside at noon, you would look down and see two versions of yourself stretched across the ground. It is the kind of thing that would make every culture on that planet develop deeply weird mythology. All of that sensory strangeness raises the biggest question of all. Could anything actually live under those two suns? Could evolution keep up with a sky that never quite makes up its mind? Chapter 4. Life. Under two suns, evolution goes exotic. Life on Earth evolved around one predictable star. Our photosynthesis is tuned to the sun's specific wavelengths. Our circadian rhythms are locked to a 24-hour cycle of light and dark. Our entire biology is a product of one star's personality. So what happens when you throw a second star into the mix? The short answer is, life adapts. It always does. The longer answer is that it would adapt in ways that are genuinely strange and magnificent. Research evaluating the potential for Earth-like planets in binary and multiple star systems to host photosynthetic life found that combinations of different star types in close and wide binary systems produce a range of stable radiation environments. These environmental conditions allow for the possibility of familiar, but also more exotic, forms of photosynthetic life, such as infrared photosynthesizers and organisms specialized for specific spectral niches. In other words, if one of your suns is a dim red dwarf pumping out mostly infrared radiation, evolution might produce plants or plant-like organisms that look jet black. Why? Because to absorb every scrap of available infrared light, you need pigments that reflect almost nothing in the visible spectrum. A forest on binary Earth might look like a field of dark velvet, drinking in wavelengths of light our eyes cannot even see. Alien, yes. Impossible, no. And then there is the question of darkness, or the lack of it. Whether a planet can be habitable or not depends on the possibility of maintaining liquid water on its surface, and therefore on the luminosity of its host stars and the dynamical properties of the planetary orbit. If the two stars combine to flood the planet with near-constant light, nocturnal life as we know it might not exist. No owls, no fireflies, no creatures that evolved to hunt in the dark. Because there is no dark, life would reorganize itself entirely around the rhythms of two suns rather than one. And now, for the part where science fiction becomes science fact. Because we do not have to speculate entirely. We have found real planets doing exactly this, and one of them is the closest thing we have to a real Tatooine. Chapter 5. Kepler-16b, the real Tatooine. In 2011, NASA's Kepler Space Telescope stared at a patch of sky in the constellation Cygnus and found something that changed astronomy forever. It found a planet orbiting a binary star with a period of 229 days. It was described as the first confirmed unambiguous example of a circumbinary planet, a planet orbiting not one, but two stars. Its name, Kepler-16b. Its nickname, Tatooine. Both stars in the Kepler-16 system are smaller than our Sun. The primary is a K-type main sequence star, and the secondary is an M-type red dwarf. They are separated by just 0.23 AU and complete an orbit around their common center of mass every 41 days. That is two stars doing a gravitational waltz around each other once every 6 weeks, and Kepler-16b orbits the whole pair from the outside, like a spectator circling a dance floor. The two stars are different sizes and different colors, always changing places. Every 41 days, these dancing stars complete a circle around one another, periodically eclipsing each other and reversing their position in the sky. The bigger star is orange and about 69% the mass of the Sun, and the smaller star is quite red and only 20% the Sun's mass. Standing on the surface, if it had a surface, you would get, as one astrophysicist put it, a different sunset every day. There is a catch, of course. Kepler-16b is a Saturn mass exoplanet consisting of half gas and half rock and ice. There is no solid surface to stand on and gaze moodily at the double.